We're going to start to graph some of these quadratics on page 6 here. So they gave it to us in factored form, as you can see. And if they give it to you in factored form, one of the easiest characteristics of the parabola to find are the x-intercepts, right? So x minus 4, when does x minus 4 equal to 0? It's equal to 0 when x equals 4, right? And then the other root would be x equals negative 2, right? So these are the two values of x in which the parabola is 0. So I'm going to draw an axis, and then I'm going to draw the parabola in blue. The parabola is going to cross the x-axis at x equals 4 and x equals negative 2. And then from these 2 points, it's going to go down and go up. Okay, so and I'm not going to draw an exact drawing, although you could, but I'm just going to say, okay, what I want to see here is that you are drawing it so that it goes through negative 2 and positive 4, okay, because that's very obvious. All right, let's go to the next one. The next one has x equals negative 3, right? That's one of the roots, and the other one is negative 5. So let's see, I'm going to draw the axes like that. And then the parabola is going to cross at x equals negative 3 and negative 5. It's going to look kind of like that, right? And last of all, there's this one here, 2 times x plus 3 squared. So obviously the x-intercept here is going to be negative 3, right? Negative 3. And negative 3. So there's two negative 3's, right? Because it's 2x plus 3 times x plus 3. So there's two roots, identical roots at negative 3, which you might say, well, how can there just be one x-intercept? There's always two x-intercepts. But remember, if the parabola just touches the x-axis, then we know that the x-intercept is actually where the vertex touches it. Okay? So that's the first part. Easy, right? Okay. Number 2. State the equation of the axis of symmetry for each graph in question 1. Now, there's a hint here. It says that the axis of symmetry is midway between the x-intercepts, which I think you guys know that, but when it comes time on a test where they ask you a question like that, it might be hard to remember, okay? This is the easiest one, I think. You can see that that's the center, right? And this is also easy. This one's a little bit hard. So negative 2 to 4, my sketch is not really good, so I can't really see where the vertex is. So what I'm going to do is I'm going to count in from the x-intercept. So I count in 1, 1, 2, 2, 3, 3. And so I can see now that the vertex is actually here. Okay? So this vertex is at x equals 1, right? Why isn't y equals 1? If it was y equals 1, the y-axis is here, so y equals 1 would be a horizontal line. We actually want a vertical line, right? We want a vertical line that divides the parabola into two symmetric sides, and that would be a vertical line with the equation x equals 1. X-axis here, x equals 1 is here, and so like x equals 1 means all the points that are along x equals 1 here, so it's a vertical line, okay? This one here would be x equals 1, 2, 3, negative 4, right? And then this one here would be x equals negative 3. Okay, so those are the three axes of symmetry, okay? Match each quadratic function with its corresponding graph. Okay, this is a little bit trickier than number 1, but it's similar, okay? So let's look at this first one. It says that I'm looking for roots at x equals positive 1 and x equals positive 4, right? So let's see. Do we have that? Yeah, actually we have this one, we have this one, we have this one. Wow, a lot of them have these roots. There's 4 with the same set of roots. So how do we narrow that down? Well, remember that when you multiply by an a factor that is positive, then that means that the parabola opens up or opens down. Well, remember that if you multiply by an a factor that is positive, then it opens up. Okay? So in this case, I have eliminated a and I've eliminated d. So now it's between b and c. Okay? And now remember that a typical parabola has a shape where it goes up the first unit it goes up 1 and the second unit it goes up 4. Why is that? Because the equation for a typical parabola is y equals x squared, right? So 1 squared is 1, 2 squared is 4, right? So since there is a 2 here, we know that the parabola is like narrower than normal, right? So between B and C, which one is the narrower one? C is the narrower one, right? So I'm going to put that this one matches up with C, and this one matches up with little a. Okay? Let's move on to B. So B says the roots are at -1 and +4. Let's see, and we can see from the negative here that it's upside down. It opens down. So let's find one with -1, 4. That would be this one, this one. It would be between these two, right? Oh, but there's only one of them that opens down, which is E. So E matches up with small b. Okay? All right. Moving on. Now we'll go to C. C has roots at +1 and +4, which is the top row again. And we can see that there's no, the multiplier here is just +1, so it does open up, but it's like a regular width parabola, so that would be this one here. And D. So D says we have roots at -1 and 4, just like the one above it, but it's not turned upside down. It opens up. The a factor is +1. So we know that it has to be the other one that has -1 and 4 roots, which was F, right? So we're going to put D here. And then here we're going to put big F. And E. So E has roots at -4 and +1. And let's see, -4 and +1, that would be this G one here. And that's it. So it has to be G, right? Has to be G. So it would be E. Okay. And F. F has roots at -4 and +1. And it opens down, right? Because it's -3, it opens down. And it's also kind of narrow because it's 3. So it opens down, it's narrow. -4 and 1 are the roots. -4 and 1 are the roots. So the only one left that has -4 and 1 as roots is this one. So it's got to be this one. It's got to be that one. We didn't even have to check to see if the 3 was the correct factor or not. So this would be H and this would be F. Let's do G. So G has roots of +1 and +4, and it opens down, right? So +1, +4 opens down. It's got to be either A or D. And how do we know the difference? Because we know it's the A factor is -1, so it's the one that's not as narrow. So it would be this one. So this would be G. This would be big A. And that just leaves the D1 for H. So this one must be H. This one must be D. But just to make sure, we'll say, okay, the roots are 1 and 4, 1 and 4. And it's turned upside down, -3, right? And -3 means it's kind of narrow. Okay, and so yeah, like -12, it's quite narrow. Okay, I'm going to show you one last thing, and we didn't need it in this case, but in some cases you might. To really be sure that you're picking the right one, okay, let's take this last example. Okay, so we want to make sure that capital D really goes with small h. Okay, so we have this equation here. It's -3 x minus 1 x minus 4. From the x minus 1 x minus 4, we know that the roots are actually 1 and 4, like this one is showing, but we want to make sure that this -12 is correct. Well, we know that the point here with negative 12 is the y-intercept. So the coordinates here are 0, negative 12, right? What if we plug in the values x equals 0 and y equals negative 12 into this equation? What do we get? We're going to get y, which is negative 12, equals negative 3 times 0 minus 1, which is negative 1, 0 minus 4, which is negative 4. And now we have negative 12 equals negative 12. And we got a true statement. So that's like one of the most basic things about equations with x and y's in it. If you plug in a valid xy pair from the graph of the equation, you should get a true statement at the end. Okay? A lot of people forget that when they get to really advanced math. They forget the most basic thing from 7th grade. And so I've just shown that actually, yes, it's true that small h does go with big D here.